Why am I teaching you this? First of all, OEE allows you to locate the source of inefficiencies. We know how important it is in lean to get rid of inefficiencies as much as possible. Where they are located, in which area of operations exactly, what the source of them is, that's something that OEE can help you with. Second of all, it allows you to actually quantify the degree of the inefficiency. You see, OEE will actually yield you a number, a percentage. For instance, you can have an OEE of 90% or you can have an OEE of 19%. The fact that it is quantified allows you to do several things. First of all, you can benchmark against competitors and see whether you're doing better or worse. Second of all, you can see whether from year to year you are improving or deteriorating. Finally, and this might sound a little bit silly, but it's not. You see, OEE is just part of the corporate and lean jargon. So, as I mentioned, this OEE is quantified and it's quantified in a percentage. If that percentage is 100%, what does that actually mean? That means that the resources that you have at your disposal, those resources could be machines or trucks, they could also be human, then we call them human resources. It means when you have an OEE of 100%, that means that those resources are available 100% of the time that they are scheduled to be available for. So if a worker is scheduled to work for 8 hours and he really works for 8 hours, then the availability is full. Okay? Now, second of all, if your OEE is 100%, it also means that your performance is 100%. So for instance, that worker who is scheduled to work for 8 hours also performs at top speed, okay? That machine that is scheduled to work for 20 hours today also performs at top speed, right? Now, perfect OEE or OEE of 100% also means that your quality rate is 100%. Okay, that means that every single thing that you produce is perfect. There are no defects whatsoever. So if the availability is 100%, the performance is 100%, the quality is 100%, we end up with an OEE of 100%. Why? Because this OEE is nothing else than the product of A, which refers to the availability, P, which refers to the performance, and Q, which refers to the quality. Just some clarification here for the A, P, and Q. Well, I wrote here 100%, but in reality you actually plug them in this formula as decimals. That means that 100% would be actually 1, alright? And for instance, 50% would become 0.5. As I mentioned, OEE actually measures efficiency, which also means that it measures efficiency loss. But where does the efficiency loss actually go to? How does the loss occur? What are the sources of the loss? I'm going to take you through the 6 big losses, a very familiar phrase within lean management and lean manufacturing. The 6 big losses. So where does the inefficiency actually go to? Imagine that we have a planned output. So this is the output that we have planned, that the production department or management has planned. But this output that is planned does not always materialize because of the availability losses. Okay, now availability losses come in 2 forms. Breakdown, okay, so if for instance the equipment that you're working with breaks down, and second of all, changeover and setup time, so the time that is needed to change the equipment or replace the equipment to deal with another form of production. And when the availability losses are actually reduced from the plant output, we actually end up with something that we call gross output, all right? The gross output is actually not the end of the story because we still have speed losses, and speed losses come in 2 forms. First form is just reduced speed. So if we're dealing, for instance, with human resources, and those human resources are due to stress, due to whatever factor, illness or whatever factor, or simply lack of training, they cannot perform at top speed, then we are dealing with reduced speed, and this causes speed losses, one of the 6 big losses. Speed losses also can stem from the following. They can also stem from idling. Now, idling is the following. Idling is when resources, they could be human or they could be a truck, are waiting. They cannot proceed with the work because they're waiting for some input. Could be a person who's waiting for specifications of an order. Could be a truck that is waiting for the freight. Once we reduce our gross output with our speed losses, we actually end up with net output. Net output is still not the end of the story because we still have possibly quality losses. Now, quality losses also come in 2 forms. They come in the form of just regular scrap and start-up scrap. Regular scrap is just those products who at some point after the process has warmed up and is working are produced and they're defective. We call them just regular scrap. Now, startup scrap is different. These are typically those defective items that are produced when you just started the equipment. Why do we make a distinction between these two? We make that distinction because typically they have very different sources and reasons, and also different treatments. Startup scrap is typically very difficult to treat because it's sometimes inherent to the production process. If you worked in a printing industry, for instance, you know that very often at the beginning when you start printing, those first magazines or newspapers, etc., tend to be a little bit defective, so defective that you basically throw them away, treat them as scrap. That has not so much to do with the fact that your equipment is malfunctioning. It just has to do with the fact that it needs time to warm up, right? Now, once we incorporate the quality losses, we end up with the valuable output. So you can see there's quite a big difference sometimes between the planned output and actually what we end up with, valuable output. A word of caution here. Planned output, gross output, net output, sometimes depending on the source, they get different names. But what generally does stay the same, there is a lot of consensus about how we refer to this: availability losses, speed losses, and quality losses. This is not really depending on the source. You find them in many sources, but they sometimes you find them under different names. Doesn't even really matter. What matters is that you understand the concept and what OEE eventually does. Now, as I already mentioned, this OEE is actually calculated by multiplying the availability rate by the performance rate by the quality rate. But how do you calculate this availability rate, performance rate, and quality rate? Let's start with the availability rate. The availability rate is simply calculated by taking this gross output and dividing it by the planned output, which is what we do here, alright? So whatever comes out, that is then the availability rate. Second of all, how do we calculate the performance rate? Well, very simple. We take the net output, as you see here, and we divide it by the gross output, what you see here, right? Now, finally, how do we calculate the quality rate, or Q? We take the valuable output, which is what you see here, and divide it by the net output, so this formula. Not really complicated. We're going to now apply it to a concrete case, and we're going to choose as the context for this case the IT sector, just to show you that there's a wide applicability of this OEE, and it's not just a manufacturing thing. Alright, so let's start with an example. Let's apply. Alright, so let's actually start applying this to a fictional IT company. Let's assume that this IT company has a very, very cheesy name. Let's say IT for you forever, written in this 1990s, 1980s style that used to be hip and now is actually just cheesy. That's the only word. Anyway, it doesn't even really matter. At the start of the project, management scheduled the programmers for a total of 150 hours on a certain project. That project could be to write code to, I don't know, for a video game. Doesn't even matter. In total, in this period, the company, IT for you forever, experienced 8 hours in terms of changeover times and setup time. Changeover time and setup time is basically when you switch from writing code to a different kind of code, or when a colleague takes over, or when you need to start a new software in order to be able to code, etc. All in all, this all combined was 8 hours. The project also was faced with 5 hours of breakdown. So when, for instance, the software was not available or working, or the hardware was not available or working. There was also 7 hours of waiting, in which resources, in this case human resources mostly, were waiting for instance, instructions, or waiting for input from colleagues or input from management. Finally, the speed was 90% when the human resources were actually working. How do you calculate this 90%? It's very simple. You look at your long-term average speed, and speed in this case could be the amount of lines of code that someone can write, for instance, in a certain hour. You look at the long-term average, and you are generally able to put that at 100%. Then you compare that long-term average with now your average. And if that average is now 10% less, that means that your speed is 90%, your 10% loss of speed. Finally, the defect rate would be 5%. That means of the amount of codes that they wrote, 5% was wrong. Alright, this being said, let's start calculating OEE. The first thing that we have to do is calculate our gross output. So we have the planned output, and now we need to calculate the gross output, because remember, at the very end we want to have, for instance, the gross output and the planned output to calculate the availability rate and the other two rates. So let's calculate the gross output. Well, the planned output was 150. The availability losses are the 8 hours for setup and the 5 hours that we lost on breakdowns, which is in total 13 hours. If we reduce this 150 hours, which is our planned output, with our availability losses, we end up with 150 minus 13, which is 137 hours. The next thing that we need to calculate is the net output. Why? Because when we have the net output and we just calculated the gross output, then we can calculate the performance rate. Let's calculate the net output. How do we calculate it? We take the gross output, what we just calculated was 137 hours, and we reduce it by the various forms of speed losses, okay? And then we calculate the net output. How do we calculate the speed losses? Well, first of all, we have here 7 hours of waiting or idling is what you see here, okay? So 7 hours of waiting or idling. That is when those human resources, the programmers, are waiting for instructions. They're waiting for work from a colleague to reach them, etc., etc. They're idling. But then we also are faced with the fact that our speed is only 90% of what it should be, okay? So there's a 10% loss of speed. Of the 137 hours that was the gross output, we have to first subtract 7, because during 7 of those hours there was no working, just waiting. Now remember, our speed was 90% when working, so we have to reduce the waiting part, alright? That is what we do here. Of the 137 hours, we reduce 7 hours because there was no working at that point, but only waiting at that point, okay? And that means that of the 130 hours reduced with the waiting, we were working only at 90% speed. That means that we lost 0.1 or 13 hours there as well, okay? So we had lost 13 hours here, 7 hours here. In total it is 20, which is what you see here. So how do we calculate the net output? We take the gross output, which was 137, reduce it by the total speed loss, which is 20. Cumulatively, we end up with 117 hours, which is our net output. So by now we have the gross output and the planned output, which means we can calculate availability rate, and we have net output and gross output, which means we can calculate performance rate. We only need to calculate the quality rate, for which we need to have the calculation of the valuable output. Let's calculate that, because that's the last thing that we need to calculate this. The quality loss is 5% because 5% of the lines that are being written are containing some form of error and need to be reworked, which means that the 170 hours of work, 5% of that was basically bad quality, poor quality. This does assume that the amount of work was distributed homogeneously over those hours, but that's quite a realistic assumption. In fact, it would be unrealistic to not assume that. So we have our valuable output can be calculated by taking the net output and reduce it by the quality loss, which is in this case 5.85 because it's the product of this and this. So which means that our valuable output is 111 hours. Remember, of the 150 hours that were planned, scheduled, only 111 hours were actually valuable. So now we approach the end. We need to calculate OEE, and OEE is calculated as the product of A, P, and Q. A being the availability rate, P being the performance rate, and Q being the quality rate. Well, A is calculated like that, gross output divided by planned output. We just calculated those, so no need to explain them further. And you reach 91.3%. P is calculated as such, net output divided by gross output. We just calculated these, so and then we reach at this value. When we multiply them, and remember you have to multiply these as decimals, so this one becomes 0.913, and this one becomes 0.854, etc. When you multiply them, you read 74% as OEE. Now, is that acceptable? Depends on your industry, depends on your norms, but at least now you can compare and you can benchmark, and you know where the biggest quality losses are. Where are the biggest quality losses? It's the performance, which is costing you the most. Not that you're excelling in the other two, but this one costs you the most. So you have also located the biggest source of this efficiency hemorrhage. At least you know now what you have to do to improve it. Thanks for the attention. Have a great day. Hope to welcome you to the next lecture.